Hey everybody. This is Professor Vaccaro here on a Saturday morning. I kind of felt bad about our little last lecture, so I wanted to put something together for you that might help you with this nth root business. Let's look at these slides I put together for you, and then hopefully it might be a little bit help. Otherwise, I can probably send you a few YouTube presentations on the topic as well. Let's take a look. It's only about 15 minutes I have here, so it might be enough to kind of get you jump started on some of the problems I gave you. Looking at the problems assigned in class, I covered three major, really three steps to talk about. This picture's not coming out real well, is it? Let's try this again. Okay, so steps I covered in class in dealing with nth roots. Find the cubes for the cubics. In other words, look for cube numbers in the cube roots. Notice the n or index and the radicand describing the root number a, and b is the base number of the radicand. So I proposed this sort of symbolic representation of a to the subscript n, or to the root of n, to give me a base number. So the second thing I talked about was to set one house into two houses, or one radicand into two radicands. And this was sort of the formula, or this was the numeric, or the symbolic representation. The nth root of AB can be described as the nth root of A times the nth root of B. You don't see the multiplication symbols there, but it's multiplication. And last, recall that the cube number in a cube root become the actual base number. An example would be the cube root of 8 can be described as a cube number, so we can say 2 cubed cube root is just the base number 2. So let's look at one of the examples, or maybe the problem I assigned in class, and I kind of scrambled to get it on the board, but a lot of you were already sort of tossing up, kind of giving up a little bit, but don't give up. This is something that's going to kind of get better with time. Here's number 47. Simplify the expression. Assume that all variables are positive when it's supposed to be when they appear. So if I have the cube root of 16x to the fourth y, you can see that first term, 3x times, and I put that multiplication symbol in there. It's not in the book, but multiplication is implied, the cube root of 2x, and then plus 5 times the cube root of minus 2x to the fourth. So if you recall doing this one, steps to cover, let's go through the first step. The first step is, let's look at the first expression, the second expression, or the middle expression, and the last expression to that problem. I broke it into three parts. We're going to do, so there's the problem itself, number 47 I think it was, and I broke it into three different parts: first, middle, and last. Let's look at the first, right? The first term, let's see if I separated that. I guess I did. The first term has two separate numbers with the cube, so that have a cube in them. In other words, 16 and x to the fourth power. 16 is not itself a cube number, but there's a 2 times to the third power inside of it, so there's an 8 in there. And so if you kind of have to get to know your cube numbers a little bit, but really you only have to get to know that maybe the first 5 or 6 of them. And then anytime you have an x squared, or x cubed, or x to the fourth power, and we're looking for cubes, really it's just subtracting from the exponent. So the other one is, from that problem, is the x to the fourth power. I broke that down in the first term. So if you can see the the 16th I dealt with as the cube root of 8 times 2. And then I dealt with the x to the fourth power. I left the y alone I just left it alone because there's no way we can split that out. And then x to the 4th power can become x cubed times x to the 1, or times x. So so we have two things inside that first expression. So here's the problem again. So now we're going to look at the second expression. Well, the second expression has no cube terms. Let's take a look at it again closely. I got minus 3x times cube root of 2xy. So 2 obviously is not a cube number, nor is x or y. So we leave it alone. We'll use it later. In the problem, I repeat the problem again, the third term is plus 5 times the cube root of minus 2xy to the 4th power. So we look for the third term here. The third term, we have one, even 2. You don't see the second one. There's a minus 1 in there. So what I did is, we do have two terms in there that we can cube. Number 1, we can cube the minus 1. We can get a negative value. A negative 1 cubed, for example, is still negative 1. And then we've got the y's. I broke the y's down to y cubed times y. So what's maybe not so obvious was the minus 1. So if you pull out that minus 1, you'll notice that it'll change that 5 to minus. So here's the problem again, kind of repeating the same problem a little bit. And the first term is summarized as the cube root of 16x to the 4th y is equal to 2x. Remember, I pulled that 8 out to become 2, and I pulled the x to the 3rd power to come out as x, comes on the outside. And what's left is just 2y, the cube root of 2y. Second term stays the same, and the third term is simply minus 5y cube root of 2x. Notice that minus 1 came out, because minus 1 is a cube number, or even 1 is a cube number. So if we put all these terms together, almost done here, a lot less than 15 minutes, but bring all the three terms together, and we can combine the like terms and simplify. Now, like I said, like I mentioned, kind of got chopped off there, but that's a 2x in the front. Cube root of 2xy minus 3x times the cube root of 2xy, and minus 5y cube root of 2xy. So what we did was I collected like terms. The first term is a 2x, so I can subtract those two. If I have the same base radical symbol, I can add or subtract those numbers, and I'm subtracting here. And so if I subtract 2x minus 3x, I get minus x minus 5y. And the last step, I guess a lot of people were asking about, is kind of goofy, but not necessarily makes it right or wrong. But you can pull out a minus 1 out of all those expressions, or those first two expressions, and factor it out to get x plus 5y. Factor it out means you just keep it on the outside, the cube root of 2xy. So there's number 47. I'm going to try to put together another one on fractional notation, fractional exponents later on today, but I'm going to try to send this all to you, to your emails, hopefully get to it before next week. Hope you're having a good weekend. Looks like the weather's kind of nice. I'm ready to go for a bike ride myself, my fam, and hopefully you're enjoying it too. Talk to you soon.